Welcome. Thank you very much for attending this session. I hope everyone had a good lunch break. My name is Vasiliy. I work as an independent software consultant and freelance developer. And today I came here to talk with you about architecture components and show you some ways in which those components, those new additions to Android framework, might harm your architecture. I would like to thank guys from Mobilization for providing me with such an opportunity, and everything they did was very professional, including taking care of last-minute cancellation of my flight yesterday. So they really did a great job. So let's start. Before we come to talk about architecture components, we need to understand what architecture is. And the previous speakers, and I guess in other rooms too, mentioned many times architecture. But what is architecture? When we decide whether our application is going to work online or offline, are we talking about architecture decision? When we're deciding how to package our application, how to distribute top-level packages in the code base, is this an architectural decision? Dependency injection. To use dependency injection or not to use. Is this part of our application's architecture or not? Unit testing. That's hard. Unit testing. Is it part of our application architecture? It's external to our main code base. Well, that one will be very easy because we had a talk about these architectures just 2 hours ago. Event bus, this library that allows you to send events to many components inside your system. Is it architecture decision to use it or not? Is it part of our application architecture or not? Design patterns in general, the choice of design patterns. Is this architecture? And in general, which is very related to our topic at hand, the choice of libraries that we choose to use in our project. Is the choice of the libraries an architecture or not? So I'm sure that if I would ask any of you those questions, I will get many different answers depending on your perspective, on your experience, and the way you are accustomed to code. But those different answers probably reflect the fact that we don't have clear definition for what architecture is and what it isn't. So in order to get this, this led to emergence of several approaches to applications architecture. So one approach is architect everything. And in today's development community, this approach is probably non-existent anymore. I read only in books that it was very popular in the 90s and early 2000s, where these people, software architects, were drawing these massive UML diagrams where each part of the system was written and designed and given a name even before one single line of code has been written. So today this approach is not very popular anymore. This one is the state of the art. Probably I myself had this experience in 2 Scrum teams, right? So we get requirements from the client and we vote how long will each of these requirements take to implement, and then we straight ahead go to implementing those requirements without discussing any architecture aspects. So we don't have time for that. We don't need documentation. We need nothing. Just make it work. So it's very popular today. And there is another approach, which is the middle ground, architect something. We will get to what something is, but that's another valid approach. And I don't have the facts or the ability to convince you objectively that the first 2 approaches are not good, but just the gut feeling that since these are the extreme approaches, they are probably wrong. So what we probably want to have is something, architecting something in our applications and not over-architecting and not under-architecting. But how do we define this something? How do we find what we need to architect? And in order to address this question, I reached out of Android community to people who were architecting applications long before Android came to life. And we will take some short look at their ideas. So Grady Butch said this. And please note the highlighted word. For those of you who might not know who Grady Butch is, he is the guy who invented UML class diagrams. Initially, class diagrams were called Butch notation. So he's very prominent in software community. Martin Fowler, who is chief scientist, I think that's his title, chief scientist of ThoughtWorks, said this. And please again, note the highlighted word. Yuval Levy, who is much less known than previous two guys, but he is very well respected in some communities. Yuval is CEO of iDesign, a company specializing in trainings for software architects. So Yuval Levy kind of took it to the extreme and said this. Yuval said that if it doesn't change, don't even bother to show it to me. It is not important by definition. Something that is not changing in my application is not important. It is not part of my architecture. Don't show it to me. So the common theme among those three very prominent architects is that architecture is somehow related to change. And my definition of architecture, which is, I think, is coherent with their ideas, is that architecture is essentially our attempt to manage risks involved in changing requirements. So we know that requirements will change, right? That never happens that we get all the requirements up front. So in order to prepare for those changes, we need to perform some architectural activities, take some architectural decisions. And the decisions that we take or make will determine the cost of future changes. And as with any other risk management activity, we cannot be prepared for all the possible risks that can come into play. Therefore, we need to choose. We need to choose a subset of possible future changes that we are optimizing our application for. And this subset will constitute the application architecture. And what is sometimes surprising people is that in order to do architecture, in order to come to a quality architecture, we need understanding of the business domain targeted by our applications. And I've seen several times how very senior software developers who worked a long time in some companies were promoted to ranks of architects and failed miserably when this happened. And in my opinion, the main reason for this inability to become an architect is here. There's not totally, but very different set of skills that you need in order to be able to come to a quality architecture for your application. And it is different from the set of skills that you need as a software developer. So software architects, they are much closer to product development than usual software developers. And it is change of mindset that is required when someone is being promoted to architect's rank. And if this guy does not get any education, help, guidance, it is very possible that he will continue to carry his duties as a software developer while he is in architect's position, and the thing will deteriorate the product's architecture. So, if architecture is our decisions that allow us to cope with future change in requirements, how do libraries, different libraries that we might use in our applications, how do these libraries enter the picture? Can libraries become part of our application's architecture? I would say that the answer is yes. If the libraries that we integrate into our applications address the core domain problems that we are going to solve. And in this context, one quite surprising example of a library that addresses core concepts of our applications are third-party login libraries. For example, Google SDK or Facebook SDK. We are not accustomed to think about integration of Google login as part of our application's architecture. But if you think about it, once we decide that we want to support Google login, we need to make changes in the clients, we need to make changes on the server, and we cannot easily reverse this decision. You know, if our users are logging in into our system using Google login, and one day we decide that it is not good, and we want to close this path, we want to force them use our native login system, we will inevitably use many users. So integration of third-party login systems is become part of our architecture, because the other core domain of our application, which is to log users in. Another circumstance when library becomes part of our application architecture is when it was integrated badly and became too coupled to many other components in our application. And in this context, a classic example would be event buses, right? I personally like event buses. I use event buses in all my projects on Android and for backend as well. But I do acknowledge the fact that event buses are very easy to abuse. So if you are not careful, very quickly you can find yourself in a situation that the core domain, core functionality of your application is encoded and stored in this quite random flow of events, and some events generate other events which generate other events. And then when you come and try to understand what this application does, you need to trace tens of events interchangeably, and this becomes very time-consuming and difficult. So in these situations, event buses, which are great libraries in my opinion, become part of our application architecture because they were integrated improperly. However, in most other cases, I would say, libraries should not become part of our application's architecture. They are not addressing core domain of our application. They are helping us build some solutions, but they are not part of our application architecture. And in this context, we will take opinion of another prominent guy, and I guess he doesn't need an introduction. So that's what Uncle Bob said. And even though he said that about frameworks, I'm quite sure and confident that he wouldn't mind us to stretch this sentence to all libraries altogether. So libraries should not become part of our application architecture. Right. With this in mind, we can finally come and discuss Android architecture components. Are they part of our application's architecture? So this is the set of libraries which provide very general functionality. This functionality is not related to any business domain specifically. These libraries help us to build very common solutions in our application, but they will not help us address our business domains. Therefore, these libraries should not become part of your application's architecture, which means that Android architecture components are not architecture components. Well, yeah, it's funny, but it is the way it is. And it might be a little bit naming misunderstanding or some unfortunate naming. However, we do know that naming is very important. And when I screw up at naming in my code base, when I screw up, the impact of this unfortunate naming will be very limited. Okay, I will suffer, my teammates will suffer, programmers who will come and try to maintain this application in the long run can suffer, but there is a limited amount of people that will be exposed to this bad naming. However, when mistakes are made in naming of libraries that are intended to be used by millions of developers who build applications for billions of users, I would argue that this is a big problem and a big warning sign for all of us. So, after talking a bit about architecture companies in general and the fact that they are not related to our application's architecture, let's talk specifically about some design and implementation details that you might want to consider before deciding whether adopting these architecture components in your applications is a good idea. So let's start with live data. And in order to understand what live data is, we need to get back to our usual and standard observer design pattern. And I'm sure I don't need to introduce you observer design pattern, but just to have this common base on which we will build in subsequent slides. So we have three playing entities in this pattern. Client, which is interested in some events that happen in the observable, and the observer interface, which client implements. Then the client registers itself with the observable, and the observable notifies the client through this interface when the events that the client was interested in happen. That's probably one of the most used design patterns in the world, and everybody knows it. So, what's live data then? How does live data play in this picture? Well, we start with the same three classes, and we add another one, which is called live data. And the client still implements the observer interface, but now instead of directly registering itself with the observable, the client gets a reference to live data from the observable, and then registers itself with the live data. The observable then pushes data changes into the live data, and live data is the one responsible for notifying the client. So please note, first thing, the picture became more complicated. We had three objects and three communication paths among them, between them. Now we have 4 objects and 5 communication paths. So this is the more complicated scheme. And the other very important thing that we need to understand, which is quite subtle but very, very important, and we will be talking about it in details, is that the observer interface is no longer under our control. Before that, when we implement or stand on or custom observer design patterns, we decide how observer interface looks. However, if we go live data way, observer interface is a closed interface provided by the framework, so we do not have control over this interface anymore. And the previous scheme, of course, does nothing magical, because in order for live data to do all this tricky magical stuff and handling lifecycle for us, we need to add another object into the picture, into this set of objects, which is lifecycle owner. So here it is, lifecycle owner. The client gets a reference to lifecycle owner in some way and uses this lifecycle owner when it registers with register for notification from live data. Live data then can observe the lifecycle owner in order to understand when the client's lifecycle transition happen and take some actions when it happens. So we started with the very simple observer design patterns. 3 entities, 3 communication paths. If we want to use live data and take advantage of its capabilities, we end up with 5 objects and 7 communication paths among them, between them. So this scheme is at least twice as complicated as the original one. And we lose control over observer interface. Keep that in mind. So let's contrast them. If we use live data instead of regular observer interface, observer pattern, we need to write slightly less code. At least this is true in very, very simple circumstances, okay? When we want to get just data from the observable. Then we can spare some code. The other thing that this scheme allows us is to lower the risk of memory leaks, because live data now will take care of unregistering itself when the observer dies. However, it comes at a cost. One thing that we already saw is that the scheme becomes much more complicated. And it's not only complicated in terms of number of objects and interaction between them, it becomes also more complicated in terms of life cycle itself. So the premise of live data was that it will release us, Android developers, from understanding and handling life cycle of activities and fragments ourselves. However, in practice, I would argue that it does not achieve that and only complicates the matter. For example, if you look at the interface, at the API of live data, you will notice that it has several methods for registration. One method takes lifecycle owner as a parameter, and the other method, observe forever, takes no lifecycle owner as a parameter. So forget for a little that all of us are very experienced Android developers. Think about some guy that just finished his studies and comes to his first job as Android developer and needs to understand how to work with this live data thing. He opens live data's API and he sees those two methods and he needs to decide which one to use. In order to understand and to decide which of these methods he should use, he will inevitably need to understand what lifecycle owner is and what lifecycle is. So we did not spare this poor guy of learning about lifecycle. All we did is throw this lifecycle at him the minute he entered our codebase. Furthermore, since live data exposes observe forever method, we are still at risk that this poor guy will misunderstand the guidelines and will invoke observe forever and forget to unregister. So this memory leak that we so willing to avoid, it is still possible. There is nothing that prevents this poor guy from making a mistake, the same mistake that we can make with the usual observer design pattern, forget to unregister, and here we are, back in the same situation, memory leak. Live data is unfamiliar. Okay, as we said, observer design pattern is probably the most widely used design pattern in the world, or one of the most. Live data, on the other hand, is like, what's that? Someone who comes to Android development from another discipline will have a hard time understanding why would he use live data instead of the usual familiar observer design pattern that worked so well for the past, I don't know, 40 years? And we shall not underestimate the cost of this ramp-up. And the last thing is the loss of a control over observer interface. And I would like to take this one into more details, because it is important. So, when we implement custom observer pattern, we have total control over observer interface. So, guys, do you think you can guess, make an educated guess about how this interface will be used? Okay. Is there anybody who thinks that he can't guess what will be the usage of this interface? So, first of all, the usual observer design pattern allows us to define name revealing, intention revealing interfaces. So just by looking at the name of the interface, we can infer what this interface will be used for. And the interface will have some methods, and the method can have custom names. Well, that one maybe is not very fortunate. It can be shorter, of course, but what I wanted to show you is that it is up to you to decide how to name those methods, and the names of those methods will also help to reveal the intent of your design, the intent of your application. And then at some point of time, you get to change in requirements. Happens. And then you realize that what you need is to add another parameter to this method. And if you use custom observer interface, it is very easy. You just add another parameter to this method, you refactor your code a bit, you refactor your tests a bit, okay, and your tests are still passing. You add additional tests to handle this new parameter, and you are good to go. You handle the change in requirements in a very graceful and efficient way. And then, of course, you will find yourself in a position that you need to add another method. Because let's be honest, we never handle all the edge cases and error cases up front. There is always something that surprises us along the way, and the interface that was designed to use in this happy flow, you know, product guys come to you, don't care about errors, just ship it, we have clients waiting, you know, and then the application crashes, and then you understand that your reverse G-coder is pulling some web API, and there are many error cases that can happen in this situation, and you actually need to handle them. So you go and add another method. And again, this is not a change, this is an addition. So you refactor your code, you refactor your tests, you make sure that all the existing tests pass, you add additional tests to handle this method, you are good to go. And then, one day, happens unforeseeable circumstance, and you need to implement some kind of priority notification. So the first observer that handles this reverse G-code data wants to notify the observable that stop notifying other clients. Stop, I handled it. Okay? It's very popular in Android view classes, right? That this on-click event or on-something event, and views just return true when they handle this event, and the system does not notify other views about this event because the system assumes that this view took care of everything. So that's totally possible to happen in our application as well. And we can easily handle it. And this change might be a bit more tricky than the previous ones, but still, we are not refactoring anything of a big complexity here, you know. We need to add this return value, and we need to refactor our tests and add additional tests, and we are good to go. And now, let's look how does this observer interface from live data look. So here it is. We lost intentionally valuing names of the interface. We lost intentionally valuing names of the methods. We lost ability to add additional parameters. We lost ability to add additional methods, and we lost ability to return value. And there is the only thing that we can control in this interface is the generic return type. And yes, you can do some very smart manipulations like wrapping your error cases inside an object and blah blah blah, but these are tricks. These are actions that you are forced to take because you integrated live data instead of usual observer design pattern, and now you kind of follow the limitations of the library. That's not very good approach. And of course, you will never be able to return value from these methods. Okay? Those are fire and forget methods. You cannot return value from them. So this change you will never be able to support. And if it happens that you want to support this change, you will want to refactor to the usual observer int design pattern. And then you will find it very difficult because live data sits at the interface of your observable. So if you want to refactor it to the usual observer design pattern, you will need to first of all refactor all your tests, not refactor, change your tests, because live data and observer are different. You will need to change your tests, so you immediately lose this safety net that a good test suite provides to you. And then you will need to refactor the code base, and then you will need to make sure that everything is taken care of. And then you will need to take care of the bugs that slipped in between those activities. All right, so that's, in my opinion, the most problematic part of live data framework. We will not have time to talk in details about lifecycle and lifecycle owner and all this stuff, because I do want to have some time for questions at the end. The only thing that I want you to know, to think about, is that activities and fragments are God objects. Okay, they are God objects. They have too many responsibilities. They do everything on Earth, but the one single responsibility that truly belongs to activities in fragments is handling of life cycle. Okay, think about it. No matter how simple or how complicated your activity is, it will always have the onCreate method. Always. So the sole purpose of existence of activities and fragments is to receive those callbacks. So if we want to delegate something of our activities and fragments, it should be everything except handling of the life cycle. And handling of life cycle events. A life cycle framework alongside other classes allow us to delegate the only one responsibility that is truly belongs to activities and fragments, which is to handle life cycle events. And if we do that, we will find ourselves sooner or later, and probably sooner than later, in a situation where in order to understand what happens when one activity starts, we need to go and visit 5, 6, 10 independent classes and assemble this knowledge, this understanding of what happens when this activity starts from 10 different classes. That will be very difficult to read. Okay, I will share the slide with you, of course, so you will be able to go through pros and cons yourself. Now, ViewModel. That's my favorite part. So, ViewModel, right? And let's start with a simple question. Can ViewModel be used with model view presenter pattern? Think about that. Can we use ViewModel in our standard model view presenter? And the that's the model view presenter, by the way. And the answer is yeah, of course. That will be just one example. Okay, we can have ViewModel inside our presenter, and ViewModel keeps the data upon configuration change, and presenter uses that data. So how do we call this design, this architectural pattern? MVP VM, some other combination of the same letters, shorten it, longer it? No, of course not. This is still the same old model view presenter pattern. And the fact that presenter uses ViewModel is internal implementation detail of the presenter. It is not visible to the outside world. So this is still our usual model view presenter. What does it tell us about the naming of ViewModel? Well, it tells us that ViewModel has nothing in common with MVVM design architecture pattern. It tells us that ViewModel is misleadingly named, and not only it show us, let's say that, misleading intent behind this class, this name does not show us a real intent. Okay, you take someone who is not Android developer and you ask him, what is the functionality behind ViewModel? And this guy will never say you, well, ViewModel is kept upon configuration change, so it is basically an object which is logically scoped to activity and fragment. You will never hear that. So not only this name is misleading, it does not reveal the true functionality behind ViewModel. And it's the second instance of unfortunate naming that we see today. So by that time, I personally say, oh, wait guys, okay, this warning sign that I had beforehand, now it's a huge stop sign. Wait a minute, what's going on? And then I ask, why would I use ViewModel at all? You give me something that is improperly named, that is not revealing its intent. You push me into some MVVM framework while it is not related in any way. What's going on? Why would I use this class? So why would I use this class? Configuration change, right? That's the use case, right? We need the ViewModel in order to handle configuration change. But then, wait a second. ViewModel is the new addition to Android framework, and config change is very old stuff. So how did we handle configuration change before ViewModel appeared? Well, we did it this way. Okay, for the later watches, I would like to state that nobody came up and left the room in rage, shouting, "This guy uses Hungarian notation, I'm not listening to him, he's stupid." Alright? No one did that. So please, stop this stupid, useless flame war. Alright, so ViewModel configuration change had been handled by saving and restoring the state. And now you could say, well, alright, but this is clumsy. ViewModel is such a simpler solution, so if we can replace this one with ViewModel, then we will probably be better off. And I answer for that, but we can't. ViewModel will come in addition to this mechanism, not instead of it. And the reason why it will be only an addition is because application still must handle save and restore flow. Okay, and I don't have time to talk about save and restore flow. You will have a link at the end to my blog, and I have a very long article about why it is important to handle save and restore. But just to think about it, on my Galaxy S4, which has 2 GB of RAM, I experience save and restore on a daily basis. And if you look at the distribution of mobile devices in the world, you will notice that more than 50% of your potential users, unless you target some niche market, more than 50% of Android owners in the world have 2 or less gigabytes of data, of RAM, which means that they too experience save and restore flows on a daily basis. So your application must support save and restore flow, which means that you anyway need to have the code that we saw beforehand. And ViewModel will come as an additional code on top of that. So you can't just replace one for the other. And surprise, surprise, if we handle save and restore code, it also handles rotation, configuration change in general, not only rotation. So we come back to the same question. Why would we use ViewModel if anyway we need to handle save and restore handles config change? Why would I use ViewModel? And the answer to that is some kind of optimization. And then what I would like you to think about, do we really need this optimization? Do we really need to optimize rotation? So I often talk to people and I ask them to do the following thing. Please take your phone and start with your home screen and swipe on the screen. Count the number of applications that you routinely interact with in landscape mode. Just count them. And then divide them by the total number of applications that you counted, that you have on these main screens. That percentage, that fraction, is the fraction of applications that need to take care of rotation, okay? For you as a user. And if you take out of this application games and Google applications, I've never seen anyone giving me number above 3. Okay, so the most I saw is 3 applications, except Google applications and games, that people interact with in landscape mode. It means that for most of the application, optimization of rotation is just a waste of time. And it gets worse because even in these applications that we do interact with in a landscape mode, we do not interact in landscape mode with all the screens, right? So you can further count the screens that you interact with in landscape mode, divide that by the total amount of screens in that application, multiply by the fraction that we had beforehand, and you will come to a surprising realization. Way less than 5% of the screens that we interact with in on phones, okay, not in tablets, in phones, require or can benefit, not require, can benefit from rotation optimization. Way less than 5%. So when someone suggests to me that I need to take care and optimize rotation, I say no, that's total waste of time. I will wait for some analytics from my users, And if the analytics tell me that my users routinely rotate one of the screens of the application, then I will optimize this one screen. Okay, so very quickly, ViewModel allows us to handle configuration change more easily. And the disadvantage is additional effort and increased chance of save and restore bug, because now you can implement config change without supporting save and restore, and then you will discover that you have save and restore bugs when you get crashes from analytics. And it increases chance of memory leak, right? So if we have a reference to context object inside our view model, oh, that's a memory leak. That is something that we didn't need to deal with beforehand. And the reason why we have this memory is because ViewModel does not simplify lifecycle. ViewModel takes the lifecycle of the activity, adds on top of it lifecycle of the ViewModel itself, and forces you to think about two lifecycles. Because if you don't, you will end up having memory leak. And of course, if you really keep data inside ViewModel, then once you leave the activity or the fragment, this data is lost. And it's very common that if you need some data on screen X, you will probably need it also on screen Y and maybe even screen Z. So if you intentionally, from the beginning of the design, tie data to the logical scope of activity in fragments, you will probably end up having many duplicate sets of data in your application. So make yourself a favor and extract that data from activities and fragments to start with, maybe in some globally scoped, stored in some globally scoped object, and then you can use it whenever you want, and you don't need to think about handling lifecycle, because the data is not stored in the activity or the fragment. Okay, so it's time to summarize our discussion. Android architecture components are not architecture components. They are design components at most. If you use them, or at least part of them, because we didn't discuss, for example, room or paging, but those ones that we did discuss, if you use them, you increase the complexity of your code base for a very questionable gain. As we discussed, there's really no evident reason to use them. In my opinion, they address almost non-existent problem. And surprisingly, if you use them, they will make your future change, the future changes that you might want to make in response to future requirements changes, they will make these changes harder. So in some way, we can call them anti-architecture components, because if you use them, future changes will become harder, which means they degrade the architecture, the quality of the architecture in our applications. Okay, shameless plug, that's my blog. So if you want to read some additional interesting and in many cases controversial ideas, you are more than welcome to read and subscribe. And with that in mind, we have some time for questions. So for this, I put that, shoot it, soldiers, shoot questions at me.
Thanks for the great presentation first, and I'd like to know your short opinion on Room and the other components Google introduced recently.
Well, I tried to use GreenDAO ORM for Android, and I was a bit disappointed by it, so I'm not using ORMs anymore. So I can't really talk about Room. What I can say is that when I heard about yet another ORM for Android, I just like, well, we have at least 3 to choose from, stable, old, which work, so why do we need another one? But I really don't have this experience to answer those questions, sorry.
So it's more like a comment, not a question. So I believe that this new live data and all those things, architectural components by Google, it's not to replace architecture if you have some architecture, like a clean architecture or whatever you are using. I believe that those components are provided by Google so that new developers coming to Android, they have easier life. And because, like you said, we've got object like activity or a fragment, it was very confusing to everyone. So I would say that if you have your preferred architecture, let's say this the clean architecture, and then live data maybe it's not for you if you use RxJava and use cases or whatever you're using. But if you are a newcomer, then definitely you should start looking at this because it would help a lot. So that's my take on those new components.
Okay, so we have also another opinion. Thank you.